Okay, so now it printed me first next, then next. Now it will start calculating from next value. So from this, it will start from here. This is a while loop. Next time it will give me, it will stop here. So it is, so I'm writing the infinite loop, but still it will not keep on printing the numbers infinitely. So it will print me the numbers whenever I need those numbers. Okay. So how you can convert a normal function to a generator function just using yield statements. That's the only difference. Any queries? One more important point about generators. Let's say I have a list. Okay. So I'm giving a function called printval, a function called list, pass this list. Okay. So I'm iterating over this list here for a value in L, okay, and just yield the element. Okay. So to print the value, I need a next statement. Okay, now this will give me first element. Alright, press it and okay, so I have 5 elements. So this is 3, 4, 5, how about 6? So if I use for 5, so for 5 it will work fine. Okay, but if I try to write it more, then this will give me something, stop iteration exception. Now it is the same exception which your Python normal for loop throws when you are iterating using normal for loop. But it's just that this exception is handled internally by Python. But in case of a generators, you have to handle this specific exception. Okay, so it will throw this stop iteration exception that you cannot continue. Okay. So in generators, now it's iterator. I cannot directly jump to the 30. I have to go sequentially. So in that case, then you can do modifications here. But again, if I write a logic according to that initially traverse these elements, and then at time of 30 yield 30, then next time if you say I want to traverse from 40, then that is not possible. So this is your generators. Next thing we'll discuss is something called, let's start with Itertools. Okay, so Itertools is the built-in functions, set of built-in functions provided to improve your looping statements. Okay, so to use all the functions present in Itertools, you have to write something called Itertools. Okay, so let's say you have this list that is which contain 10, 20, 30, 40, 50. You have a tuple which contains 100, 200, 300, 400, 500. Nextly, you have a range of, let's say, 1000 to 1000. Okay, so now you have to iterate over all these elements. So you have to iterate list, then tuple, and then over this range. Okay, so I need to create one list, that is one way. So I can say L dot extend of T, then I can say L dot extend of R, and if I just print this list, then I'll get this list, and then I can start iterating, right? But let's say, take the same example, let's say you are working with a databases, and whatever data you are seeing in this list, it's like an object and you are getting from different tables. And you want to display the records from all the tables. So you need to iterate over each elements. And let's say you have 5 to 6 tables. So each time you cannot just go and do L.extend, and this. So better way to do this is something called chain. So I'll start directly writing loop for value n. We have something called dot chain. Now I can specify n number of elements here. So here I'm saying take this list first, then tuple, and then range.
So basically, Itertools is used for
only for iteration.
For iteration with different iterable
exactly,
types.
exactly. Okay. Alright. So print value. So now it will combine everything, and I'll get one iterator to iterate this. Okay. Just have a look here. So what I'm doing, instead of directly specifying this chain, let's say I'm creating this object.
Not mentioning on this chain for function.
Sure.
Exactly.
Okay. So what this chain function will do, you can specify n number of different lists, tuples, ranges, okay, whatever iterable data type you have, and which you want to iterate it one after the another. Okay. So what it will do, first iterate over this list, chain the next element after this, attach the next element after this. So in a same for loop, you can iterate using all these elements now. Okay. So when if I create this Itertools chain, and if I print this, so it is a Itertools object, it's an iterator. Okay. So just have a look here. So this is the important concept. So here I'm saying for value in O and print the value. Okay. So it will print me values. If I try to copy paste the same thing, okay, any guess? So if I do this, okay, you can see it's not printing me anything. You can see that for the first for loop, I am able to see the output. It's 10, 20, 30, okay, then tuple, and then the range. Okay. After that, it printed after one chain execution. Now I have written another for loop here, but still it didn't print anything for this. Okay.
Only once.
So whatever object I'm creating, it's a iterable object which can move in one direction only. So it will start from the first element, and it can go in a left to right direction. So once I have printed all the elements, once I have iterated over all the elements, then I cannot iterate over it next. Okay. So here if I say, okay, not subscripted. So I'm doing something like this. Okay. So now I'm printing two elements of this object. Now after chain, when I just return for value in O, it has started from 30, not from 10. Okay, so this is a iterator which can always start from left to right, and it cannot go in a reverse direction. Okay, so your iterators are always considered to be faster while traversing the elements. Okay, but one of the major point is I cannot use the same iterator again. Okay, so if I have this object and if I want multiple iterators for this, then we have something called Itertools.t, and just specify the object for which you want a multiple iterators. Now it's not necessary that it should be Itertools object. Let's say I have a list, and to iterate over that list I want multiple objects. Okay, so defaultly it will return you two objects. So now you have two objects to iterate over the same list. So in the same problem, so now I can use, okay, so this is the T I have. So here I'm writing something else. It is T of 0 because it is a tuple. Okay, so I'm saying first object, and then while iterating, now I will see T of 1. Okay, so list, then tuple, then range. After one chain execution, okay, then it started again from 10, 20, 30. So what I did, I just created a multiple objects to iterate over same chain function. Okay, why? Because defaultly I can iterate over only once. Okay. We have already discussed zip, right? So what is the use of zip? So if I want to iterate over this element simultaneously, then I can use zip function for value in zip of 10 tuple range. The only restriction I have here is the element should be same. So if I say print the value, so in each iteration it will iterate over all these elements, the first index of all the elements. If I have matching element in all this, then it will give me a tuple 10, 100, 1000, 20, 200 plus. Okay, but here I'm specifying my range, I guess till 1005, okay, 1004. Yeah, in this list I am only able to get till 500, still working fine. So still it will not consider 1005 because there is no matching element for this. Okay, so using zip, now I can iterate over multiple data types simultaneously. Okay. So earlier this zip function was part of this Itertools library, but from Python 3.0 version it is made as a library function, a global function. Okay. So we have seen the range function, right? So if I say something like this, what it will do? Right, 0 to 4. So this is the start, this is the end. When I say something like this, range of 10 to 15, this will give me 10 to 14. So I always specify an end here. Okay. If I want something that I don't know what is the end condition, I want the numbers infinitely. Okay. I will put up a one condition at that time, break my loop, but till that point, just keep on supplying me the numbers. I don't know what is the end point. Okay, I'm just searching for a particular condition. So such loop, if you want to write, then you can write using your count function. So defaultly it will start from 0 and it will give you numbers till infinity. So if I don't get out of this, it will break my program. So I'm just writing condition if value is greater than 50, then break, else let's say print value. Okay. Defaultly it will start from 0 and it will keep on supplying you the numbers unless and until your condition is executed. So for count, I can specify the start. Let's say start from 50. Let me modify my range to 70. Okay. I can specify the increment, but I cannot specify the end. Okay. So it will keep on giving me the numbers. I just need to write a separate condition. Okay. So this is your count function. We have seen when we are iterating over a list 10, 20, 30, 40, and 50. So it will start from the first element, go and it will stop at 50. Right? If I want a repetitive execution, okay. So what this cycle will do, it will keep on infinitely iterating over same list again and again. So here also I need to specify external condition. Let's say count is 0. I'm saying if count is greater than 10, then break, else do this and make sure increment the count. So now it will start keeping iterating 10, 20, 30, 40, 50. After 50, start again from 10, 20, 30, 40. Okay. So your cycle function will iterate over whatever you are specifying. So similar variation of this is your the difference between cycle and repeat. So your cycle will iterate over the data type. While repeat, it will give you the entire list here. Okay. So here, if I say repeat of Python, and it will give me same string in each iteration. But instead of this, if I write cycle, now it will start iterating over this. So P by THON, after that, start from P again. Okay. So last two functions. So these are something related to a probability. We have a list 10, 20, 30, 40, 50, and 60. So I'm saying 10. So what are the different ways of selecting two elements from this list? I need to type this. Okay, so it will give me all possible combinations of selecting two elements from this list. If I want combinations, then so let's reduce the list a bit. So I have this. So when I say permutation, now I'll get 10, 20 plus 20 as a separate elements. But in case of combination, I'll get a unique twist 10, 20 is the only. Okay, so if you want such functionalities, then you have Itertools. So these are some of the important features which you can use while iterating over normal for loops to get a performance improvement. So in Python, to get a good performance, we have list comprehension, we have map, filter, lambda, generators, okay. Then we have Itertools, and we have decorators. Okay. So the rest thing is remaining. So that way
If somebody asks like which one should we choose for for the best performance in the world, then
So what we choose are, so whenever you're writing a function, we will convert it to the generator function. Okay. Now you have a choice between list comprehension and a map filter. Obviously, you have to select map and filter. Okay. Uh, Generate and Itertools is something. If you have a loop, then obviously you can iterate over that loop using your Itertools. So it's not that which one to choose. You can combine everything together. Okay. So from next time we will start with object-oriented programming in Python, and after that we'll come back to the decorator section. Okay. So the loops and then exception handling, and then we'll come back to this topics. Okay.